All right. So objective, like I said, is talking about quadratic functions, talking about the special features. We're going to talk about finding the vertex, the X-intercepts, the Y-intercepts, the different forms that a quadratic could come in. We'll revisit all of that information. Tomorrow, then, what we'll do is we'll take a look at some of the applications of quadratics. And that's about the only thing we'll add in. Okay? So, if we take a look, here's the first part. Here's the first thing you should write down. The definition of a quadratic equation, or a quadratic function. F of x equals ax squared plus bx plus c. Most books call this standard form. This book calls it the definition of a quadratic function. That's why I put it up there. Where a, b, and c are real numbers, but a cannot equal 0. And as always, anytime you have a quadratic, it's U-shaped, it's in the shape of a parabola. Like I said, this book calls this the definition of a quadratic. You're going to hear me call this most of the time standard form. Okay, and I'll talk about that a little bit later on. This is basically your standard form. Quick question, why can a not equal 0? Because if a equals 0, 0 times x squared is no longer, that term would no longer be there. And it would go back to either being linear or quadratic, or linear or constant again. Okay? So a could be any real number, but not 0. Okay? Some of the stuff we're going to take a look at, and it's up to you what you need to write down or not. But key terms, we're going to look at the axis of symmetry. Remember, that's just the line of reflection. It goes right down the middle of the parabola. We're going to take a look at, again, the vertex is what I would say is the most important point on a parabola. It's where everything either starts and goes up from there or down, depending on whether it's opening up or down. Okay, so vertex, we'll talk about that. These two parts, leading coefficients. By the way, quick question, up in our equation here. What variable is the leading coefficient? A. So all this is saying is if A is positive, it opens up. If A is negative, it opens down. Which, again, hopefully, we talked about that in the last chapter. Okay? Positive versus negative with the reflections and those types of things. And then all of the other transformations still apply. The stretches, the shrinks, the shifts, all that stuff we talked about in chapter 1 still apply. Okay? So to be honest, most of the graphing stuff we've already talked about. But most of the time it was given to you in vertex form, not in standard form. Okay? So that you could look at what's the horizontal shift, what's the vertical shift, what is A doing to the graph. So this is what we're going to take a look at today. All right. So here's what you've been used to, and notice I told you before, I'm going to call that last form standard form. I have no idea why. This is the first book I've ever come across that is called this standard form. I'm going to call this vertex form because that's what it is. Okay? Like I said, I have no idea why this book calls this standard form, but they do. This is my 21st year of teaching, and I've never, ever seen it called standard form before. And this is the form that you've seen most often. Let me give you an example. So problems that you just had on your test. You had problems just like that on the test from chapter 1 where you had to go through and sketch the graph. And based off of the horizontal shift, vertical shift. Oh, that's all this is. Okay. For example, let's just run through this. What does the plus 3 do to this graph? 3 to the left. Remember, it's the opposite way. What does the minus 4 do? Yeah, so it goes 3 to the left and down 4, which, just real quickly, normally, remember, it's the vertex was at the origin, and then you take that, in this case, 3 to the left and down 4. That means the vertex is really just the h and the k in that equation. That's all it is. It's your horizontal shift and vertical shift. You're moving the vertex around. What does the negative do to the graph? Opens down. And what does the 2 do? makes it more narrow. Yeah, that's vertical stretch, so it narrows out the graph. So everything that's in there we've already talked about, we've already looked at. Now it's just here's kind of the formal lesson that goes kind of behind it. So your vertex is really just h and k. H is the x-coordinate, k is the y-coordinate. The one extra thing that we're adding in today that we have not talked about yet this year is the axis of symmetry. The equation of the axis of symmetry will always be x equals h. Whatever the x-coordinate of your vertex, there's a vertical line that'll go right through that as your line of reflection. Other than that, here's the other stuff, and you don't even need to write this down if you don't think you need to. If a is positive, it opens up. If a is negative, it opens down. If a is bigger than 1, it's the stretch, it narrows the graph. If a is between 0 and 1, then it's wider. Okay? So none of this is all the same stuff we talked about last chapter. So that's why I said if you don't think you need to write it down, then don't worry about it. So closer to the axis of symmetry, meaning more narrow. Further away, meaning it's wider. Okay. Any questions so far? Okay, so in vertex form, this is, like I said, this is kind of the nicer form because you can check the vertex. You know a lot of information. When you're in standard form, there's not a lot of information that's given to you. You have to then find it, okay, in order to come up with that. So if we take a look, here's the difference between the two. Here's your two forms right here, okay? We just talked about if you're in vertex form. Let me kind of come back to what I'm going to call standard form, what the book calls the definition. If I needed to find the vertex when we're in standard form, see if this right see if you remember doing this. In order to find the vertex, you take the opposite of b over 2a, and that'll give you the x-coordinate of your vertex when you're in standard form. Just for this part. Okay, we'll talk about vertex form in a second. Vertex form, you've already got it. It'll be right there in the equation. But if you're sitting in standard form and you need to find the vertex, you can't just look at the equation. You got to take the opposite of b and divide it by 2a. By the way, just a quick heads up on that. Where else have you seen this before? Quadratic formula, right? Algebra 2, same thing. Yeah. Okay? Quadratic formula. But if you remember back to the quadratic formula, opposite of b plus or minus all the square root stuff, then all divided by 2a. What do you find when you use the quadratic formula? X-intercepts. Think about this for a second. Where is the vertex in comparison to the x-intercepts? Where's it, Devin? Right down the middle. It's right in between. If here's one x-intercept and here's the other, halfway between is going to be where your vertex is. That's the plus or minus of the quadratic formula. If you add, that takes you to the one x-intercept. If you subtract all the square root stuff, it takes you to the other x-intercept. If you get rid of all the plus or minus, that's where your vertex is at. Okay? So that's kind of just to relate it back to the quadratic formula. That's what the plus or minus of the square root is actually doing. It's taking you from the vertex to the two x-intercepts. Okay? Once we find the x-coordinate, all you got to do then is plug it right back in and you find the y-coordinate that goes with it. And we'll do that in a second. So I told you, vertex is probably the most important point. Then from there, we're going to find the x-intercepts. Okay, we're going to take a look at those. We've already done that. We did that back in the prerequisite chapter, the very first chapter. Anytime you're finding an x-intercept, that's when y equals 0. So you set the equation equal to 0, and you solve either by factoring or quadratic formula to find your x-intercepts. And then the other point that we're going to take a look at is the y-intercept, which means that's when x equals 0, and then you solve for y. Whatever intercept you're looking for, just remember the opposite variable is always 0. And the idea is, even though on the test we went through and we found that starting point and then we just sketched it, now we're going to add a few more accurate points to the graph. That's where the x-intercepts and the y-intercepts are going to come into play. Yeah?
Isn't the y-intercept just c?
It is. Okay, matter of fact, if you go through and let's say we take x equals 0 and I plug it into the standard form, well, that first term's going to go away, second term's going to go away, therefore your y-intercept is c. in the standard form equation. All right, let me give you an example. Let's get into a few different examples of different ways, different types of things you're going to see with quadratics today. So example number 1. Given an equation that's in standard form, I want to find the important features and graph them. Okay? I want to find the vertex, find the intercepts, and then sketch an accurate graph using those. So let's start with the vertex. If this was in vertex form, I'd be able to just say, there it is. There's the h, there's the k. We can just pull it right out of the equation. Unfortunately, I'm not in vertex form, so how do we start by finding the x-coordinate? That's the negative b over 2a. That's what we were talking about. So in order to find the x-coordinate, you take the opposite of b and divide it by 2a. So let's do that. B value in the equation is -1. Opposite that then is +1. And if I double my a value, we get 4. In this case, not the nicest answer in the world, but it's fine. We can deal with that. So the x-coordinate of your vertex is 1/4. How do I find the y-coordinate? Yeah, just plug it back in. I say just plug it back in. It's not the nicest thing in the world. It's not. You could deal with the fractions. You could just plug it in and use your calculator. What I'll tell you, I'll save you a little bit of time. You end up getting -9/8 is what you end up with for the corresponding y-coordinate. Or negative, I think it's 1.125. Okay, if you plugged it in for, and got a decimal. So let's put that on the graph. Okay, we'll approximate it. 1/4 -9/8 is somewhere in that vicinity, right there. From there, by the way, I didn't ask you to find this, but let's just include this as part of to interpret this. Is this parabola going to open up or down from that vertex? How do you know? A value is +2. So I know from there everything is going up. Okay? So now let's find some other, and that's where you would have stopped back in chapter 1. We would have said, all right, we've got the vertex, now let's just sketch it in from there. We're going to add a few more points this chapter. Okay? So let's find the x-intercepts next. And in this case, remember that's when y equals 0. So I'm going to take the equation, the 2x squared minus x minus 1, and we're going to set it equal to 0, and then we solve. How do I solve that equation? What do we do? Factor or quadratic formula? One of the two. I will tell you this is factorable, so I'm going to do that. That's something that if you're struggling a little bit, factoring is something that you're going to want to continually work at, because we're going to be doing factoring for quite a while, even in chapters to come. We're going to be working on factoring. So something that would be worth your time to get better at if you struggle with factoring. So let's start at the beginning. Factors of 2x squared are 2x and x. Okay. Then we go to the other end. Factors of your constant term, in this case, have to be 1 and 1, because those are the only factors that give you 1. And now we need to check for signs. And if you remember, anytime a is bigger than 1, we have to go through and think back to like foiling. We need to check the inside and the outside two terms to see if I can get the middle term from that. So when I multiply the inside 2, I get 1x. When I multiply the outside 2, I get 2x. If I were to add some signs, if I wanted to add or subtract those, can I get a -1x out of that? Yeah. If the 2 is negative and the 1 is positive. Okay? Which means, in order for the 2 to be negative, that means a minus sign has to go there. And in order for the 1x to be positive, that means the plus sign's got to go there. Okay? So anytime the a value is bigger than 1. You've got to go through and check, like we just did, the inside and the outside to see if you can get the middle term. All right, so it's factored. Now what? Now we solve. Zero product property. So let's do the second one first because it's easier. First x-intercept, x equals 1. All right, there's one of my x-intercepts. How about the first factor? Yeah, if you set it equal to 0 and solve, you would end up with -1/2. There's your two x-intercepts right there. Okay, factor, zero product property. Like I said, we did that in the prerequisite chapter. You did some of this before. Okay. All right, let's add those to the graph. We've got an x-intercept at -0.5, and we've got an x-intercept at +1. There's two more points on the graph. Part of the reason I left the y-intercept for last is because it's the easiest. Okay. Remember, the y-intercept is when x equals 0, and Aiden already reminded us. What's my y-intercept on this one? It is the c value. If you plug in 0 for both of those x's, the first two terms go away and you get -1 as an answer. So c is your y-intercept. So if we add that to the graph, there's another point that I know is there. And now we have a little bit better sketch of what's going on. There's kind of what your parabola is looking like, something like that. If you notice, by the way, it's kind of a narrower parabola. Why should that make sense? Because A is 2, so there's a little bit of a vertical stretch to it. It narrows the graph. So it fits with what we've already talked about in the previous chapter. Okay. If you're in standard form, this is kind of the process. You got to find the vertex. You got to find the x-intercepts. The nice part is you have the y-intercept, but that's about the only thing you have to begin with. Okay? That's why we usually prefer to be in vertex form. There's a lot more information given at that point. Okay. Anybody have any questions on this part of it? Okay, let's go to a different type of example then. All right. So that problem, the last question that we just did, I gave you the equation and asked you to find the important features of the graph. This one we're doing the exact opposite. I'm giving you some features of the graph and asking you to find the equation that fits this. I would say when you're thinking more outside of math class, outside of pre-calculus, when you're thinking more real life, this is more real life, and what I mean by that is normally you look at data, analyze the data, and try to fit an equation to the data. You're not normally given an equation and then trying to just answer questions off of it. Okay? This is more realistic that, all right, here's the data, here's what I know. How can I fit some sort of equation for that? Based on the information you have, do you think we should go to vertex form or standard form? Yeah. And if you have the vertex, you might as well go to vertex form. So, y equals a times the quantity x minus h squared plus k. Whenever you put something in vertex form, you need 3 numbers. You need your value of a to tell you whether the parabola is opening up, down, narrow, wide, that kind of stuff. And then you need h and k, so you know where the vertex is. Okay? Based off of the vertex and a, you can sketch a pretty good graph, just like we did, like I said, previously in that. What do I have right now? I have the vertex, so I've already got h and k. There they are. I could put those in right now. What don't I have? I don't have the a value. Yeah. Why did I give you that extra point? So plug it in for x and y so that I can find the a value that goes with it. Okay? That is the whole reason why there's some other extra point that's given. It's to find the a value. Okay? So this point is some x and y. Let's plug everything in and we'll solve for a. Y is your y coordinate of your point. That's -7. We said we're looking for a, so I'm going to leave that in there. X is the x coordinate of a point on the graph, so that's 4. if I'm subtracting the value of h, that turns it into a plus sign. We're subtracting a negative. So we're adding 3. And finally, plus k plus your y coordinate, which is positive 2. So we plug everything in and we can go through and we can find a. If you're looking at this and wondering where do I start, just think of order of operations. Parentheses, exponents, multiply, divide. Our main focus will be right here. Let's clean that up. Okay, so 7 squared is 49. 49 times a gives me 49a, and then we still have the plus 2. Now you can solve for a. Okay. Now we're back to a linear equation. You got 7 in the parentheses, squared it, that's where the 49 is coming from, times the a that was already there. All right, so now subtract the 2 over, I get negative 9 equal to 49a. Divide both sides by 49. A is not a nice number, but that's okay. It doesn't have to be. So we get negative 9/49 as our value of a. Okay. So we at least know it's opening down. We know that this is going to be a fairly wide parabola because it's closer to 0. And the only thing left to do then is actually take that important information and put it into the equation. So we end up with y equals negative 9/49 x, in this case again, plus 3 squared, and then we have the plus 2 at the end. Here is the actual equation in vertex form that has that as a vertex and goes through that point. Okay, like I said, the whole reason for the point is to find the a value that fits. And again, correct me if I'm wrong, I'm pretty sure you did this last year, right? In Algebra 2, you should have done this before. Yeah. Okay, try this one. Same idea, different coordinates. Try this one, see what you do. I'll give you a couple of minutes on your own. You will have some problems like this in your homework too, so that's why I'm giving you a chance to practice this real quickly. The reason that yellow box is there is I've got the answers underneath. The answers and the work is all there, so. Find the equation. All right, let's see what you got. Let's see what you came up with. Here's what you should have ended up with. Based on the information, you should have been able to find that a is 5/4, and therefore, there's your final equation in vertex form. Any questions? We're doing okay? Hopefully. Okay, I got two other fairly quick examples. All right, so here's the next one. I gave you an example that started in standard form. We found all the features. Gave you a couple of examples where we started with the features and worked backwards. Here's another one, but different features this time. I didn't give you the vertex and some random point. I gave you 2 points, specifically the 2 X-intercepts. And actually, it turns out that this one's going to be hopefully nicer, easier than the ones we've already taken a look at. Okay? Because, if you remember that first example, we said let's set the equation equal to 0. And we'll factor to find the X-intercepts and then zero product property. We're just going to go the opposite way. Let's start with the zeros, go back to the factors, and then we can get the equation. Okay? So first question, if -6 is one of our zeros, what's the factor it came from? X plus 6. If 2 is one of the zeros, one of the X-intercepts, what's the factor that came from? X minus 2. And now, I asked you for 2 different quadratic functions. We'll talk about the second one at the end. If I wanted to find the quadratic equation, all you have to do is FOIL this thing out. Okay? If you said, here's y equals, if I multiply this out, we get x squared plus 4x minus 12. There's an equation that would have those 2 points as x-intercepts. So like I said, not the vertex and a random point, 2 specific points that we can still use to come up with an equation. By the way, what's the second one then? Yeah, Alex?
It would be -x squared plus 4x plus 12.
If you have the right idea, just one little thing off.
-x squared minus 4x.
Yeah, it's going to be totally opposite. The idea is this would be a parabola that's opening up that goes through those 2. Well, if I take the same thing and it's opening down instead, we can take the opposite of everything and say y equals -x squared minus 4x plus 12. There's a second equation. One that opens up, one that opens down. Regardless, you have those as your x-intercepts. Okay. How we doing? Making some sense, hopefully? All right, last one. And this one will be a fairly quick one. Let's say we start with an equation that's in standard form, but I want to take a look at it. I want to be able to change it into vertex form. Okay, I want to go from one form to the other. All right. So again, if I'm going to put it in this vertex form, and I put standard form, by the way, in parentheses, because again, that's what this book calls vertex form, for whatever reason. So I put it there just to remind you. I need A, H, and K. Do I have any of those? Which one, Aiden? Yeah. The A value in standard form is the same A value in vertex form. A is A. So I already know that A is 3. So I could start off by writing y equals 3 times the quantity, x minus something. What I need to find is the vertex. But remind me, how do I find the vertex of an equation in standard form? You have the right idea. Opposite of b over 2a. Yep. That's when you're in standard form, that's the easiest way to do it. So to find the h, if you will, we take opposite of b, divide it by 2a, and in this case, it's going to turn out to be a whole lot nicer. Opposite of b is 12. If I double the a value, we get 6, and therefore, the x-coordinate of your vertex is 2. So now I can fill that in, x minus 2 squared. How do I find the k value? How do I find the y-coordinate of the vertex? Just plug it back in to your original equation. It's called h, but remember, it's just the x-coordinate of your vertex. It's just an x. So if I take 2 and I plug it back into the original problem, the answer is your y-coordinate of your vertex. And what do we get? You can do this one in your head. What do you get? -7. Yep, that's what you should get. And there's your exact same equation of your parabola, just in a different form. Okay? Like I said, my hope is that there was nothing new today for you, that you've already seen all of this. That was more just a refresher for you of, oh yeah, now I remember doing that. Oh yeah, now I remember doing that. Tomorrow, the one thing that we're going to add in, like I said, we're going to add in a few applications just so you can kind of see where this stuff applies, so it's not just these random quadratic equations. Okay? Otherwise, there's your assignment for today. Back to a book assignment again. This week you'll be having book assignments again. Next week it'll go back to a few worksheets before the test. And you do have some time to at least get started on this. The 1 through 4, it's literally matching. Which graph matches with which equation? I mean, those are super quick.